name is Andy Purvis. It's my pleasure to be helping host this webinar again. I'm Director Sustainable Manufacturing at the World Steel Association, and this is the 8th webinar in our series that we've created this year in partnership with 3M to support our Steel Safety Day focus on working at heights. Today, our expert guest will share with us some really important aspects about rescue and particularly recovery from heights and post an incident. This element, rescue and recovery, it's an often overlooked part of providing a safe and effective solution to work at heights. And the webinar and the discussion we're going to have today is going to explore why rescue planning is such an important part of the process. We're also going to look at the consequences of poor rescue planning, the considerations we need to make, and think about the equipment which are available to us and to you to provide a safe and effective rescue should that be needed. Our guest speaker today is David Barker from 3M, who we've heard from before. Good to have you here with us again, David. David's worked in fall protection for 20 years or so, a few different roles, including fall protection system design, fall protection training, project management, and business ownership. Since he's been with 3M, he's had several roles, including special projects manager, fall protection system specialist, and currently he's leading a team of application engineering specialists who look after the Europe, Middle East, and Africa region for fall protection. And this team is responsible for providing technical support for customers, product training, and education, as well as supporting new products and so forth. So, David, thank you for your time. Thank you for stepping in at relative short notice, and we're very much looking forward to hearing your presentation today. I should add, if you do have any questions, we'd like to make this an interactive discussion. So if you could use ideally the Q&A functionality within the platform, that's better than chat, because with chat at the end of the webinar, all that information is lost. With Q&A, we can capture that, and maybe if we haven't covered an issue, come back to it. So please, I will come back after David's presentation, and we'll have a bit of a conversation around any questions that have come up. At the meantime, I will retreat backwards and leave the presentation to David. David, the floor is all yours.
Brilliant. Thank you, Andy. And thank you very much for that kind introduction. Yeah, you may well have been expecting Heidi to make this presentation. Apologies from Heidi. She had to take the day off today, and so I will be stepping in to deliver the webinar on rescue. So thank you. Yeah, thank you for that very kind introduction. As usual, we'll start with the disclaimer on the presentation, which we'll read through. This presentation provides a general overview of fall protection information and includes various 3M safety solutions. The webinar content should not be relied upon to make specific fall protection equipment selection, use, and maintenance choices. Local, country, or regional regulations and guidance varies, and the responsibility for the correct implementation of a fall protection program in compliance with local, country, or regional regulations is with the employer. This presentation should not be relied upon in isolation, as the content is accompanied by additional and/or clarifying information. Okay, so standard disclaimer there that we put at the beginning of this one. So a much anticipated webinar, this one. I know there's been a lot of questions have come in, a lot of requests have come in around rescue, etc. So let's have a quick look at what we're going to discuss today. We're going to have a look at what is rescue. We're going to have a look at why we need it, the types of rescue that can be required. We're going to have a look at the issues with suspended casualties. Always quite an interesting topic. A lot of opinion and differing information around suspended casualties. So we'll try and clear up some of that for you. We'll have a look at the considerations we need to make when carrying out rescues. We'll have a look at the all-important rescue planning and what we need to do. And then we'll have a look at some rescue types and scenarios that are available to you. We'll then recap that all at the end and take any questions. Hopefully, if we've got a little bit of time at the end, we'll be able to take some questions from you. As Andy said, if you do have any questions, please put them in the Q&A. We will try and answer them at the end of the webinar. If we don't get time, then we'll take those down. Please leave your details on there if you're happy to do so, and we'll always try and respond via email. Okay, so let's get into it then. So we all know about the ABCs of fall protection. We've spoken about them in the fundamentals. You know, we've got the anchorages, the body support in the form of harness, and then a way of connecting the device. But we also know that we have the D's, the E's, and the F's. So education for E, fall protection tools. And what we're going to be concentrating today is talking about the D, which is the descent and the rescue element. So, you know, fall protection really takes on all of these elements, and descent and rescue, as Andy said, it's an often overlooked part of creating a safe working at height plan. Okay. We place a huge amount of emphasis on ensuring that the correct anchor point is selected, that it's correctly installed, that it's correctly positioned. We choose the correct connecting device, be that a lanyard, a rope and grab, maybe a self-retracting lifeline. We make sure that a suitable harness is selected and that it's fitted correctly. So that could be a harness with rear attachment points, front attachment points, work positioning attachment points. But we place such a huge amount of that the rescue element of the plan is often not considered properly or even at all. Okay, it's often quite often it's actually overlooked and not even planned at all. However, rescue is critical that it is considered, because not considering suitable and sufficient rescue has the potential to cause serious injury, okay, or even cause death. Okay, so we know that work at height, falling from height, can cause serious injury or death, but actually, if we don't properly plan rescue, the consequences of that not being properly planned as well can also cause serious injury or even death. Okay, so why do we have to do it? Well, first of all, quite often, depending on where you are in the globe, it's a legal requirement. If I take where I'm based in the UK, for example, we have the work at height regulations. That sets out the requirements for planning, supervising, and undertaking work at height. And it also says that we must plan and provide for rescue. They say that it needs to be appropriate and foreseeable for the situations that can arise. And the procedure for the process and rescue should be recorded in a rescue plan, which should form part of the tasks of a safe system of work. Okay, so again, I would always encourage you to this is a webinar that's going out globally. I'd always encourage you to understand what the local or regional requirements are where you're based. But more often than not, rescue planning will actually be a legal requirement. It will probably be written into the form of regulations or the codes of practices that you're required to follow. So there is a legal element here that imposes upon us the need to plan for rescue. There are also physical consequences to not planning rescue at height. You know, as we mentioned, we know the consequences of falling. We know the types of injury that can occur, but there can be physical consequences to not planning rescue properly. Okay, so when we look at why we're doing it, we've got a legal requirement pretty often to do it. It's almost certainly going to be in those codes of practices and those regulations. And also, we need to make sure that we do it, because if we don't, there is potential serious physical consequences that can come from not planning. So when we talk about rescue, let's have a look at some of the scenarios from which rescue can be required. We can require rescue from height. So if we have a suspended casualty, okay, so if we are working in fall arrest, we can have a requirement to rescue somebody from height from being suspended in a harness. So we've put together our fall protection plan. It relies on fall arrest. Unfortunately, a fall has occurred for whatever reason. The equipment's done its job, and we're now left with a suspended casualty. Okay, the same could also be true for rescue from things like nets, So we looked earlier at, you know, perhaps if they're doing roof work and you've got netting, that we also require maybe a fallen casualty might need rescuing from collective equipment, such as a net as well. We also have the possibility that we require to rescue somebody at the same level. Now, this is predominantly more prevalent within confined space. And I'm not going to go too heavily into depth on this side because there is a confined space webinar coming up, which will touch more on this, but it can often be that we require to rescue somebody from the same level. Okay, they might not even have been involved in a fall. They could have been injured, but be on scaffolding at height, and they still need to be got down and rescued. Okay, so we still need to think about perhaps rescuing people from the same level. It may be that they're in at the same level in a confined space, maybe in a tunnel or a crawl space, and they need to be brought out at the same level. We also need to consider rescue from below ground level. Again, very, very typically, this will be in confined space. But we often, you know, one of the things that we need to consider is not just access and egress to confined space, but it's also the rescue from confined space. What happens if something goes wrong? What happens if the casualty becomes incapacitated and they need to be rescued? So, and with below ground could also be something like from within the hold of a ship, for example, during unloading. It can be in a pit, it could be in a tank. Okay, so there's lots of scenarios where we need to rescue somebody as well from below ground. And the final type of rescue that we're going to look at and need to consider is evacuation. Okay, and so that's not necessarily where we need to, where an accident has happened, somebody's fallen from height and they've become suspended in a harness, but where we actually need to get out of a situation that is our workplace at height. So the one that's shown there is a wind turbine, but I mean, equally, that could be in a crane, for example. Okay, if you're working in a crane cab and your egress route is compromised and you need to get out quickly, then you need to have an evacuation plan. You're still rescuing somebody from height, you are evacuating them rather than recovering them from a post-fall suspension scenario. So we can see that rescue and recovery really, we often really just think of it as a fallen casualty hanging in a harness, but actually it can cover rescue and recovery from the same level, from below ground, or the need to be able to evacuate somebody from a situation at height which they need to get out of quickly, and by which their normal means of escape is no longer accessible. Okay, so rescue and recovery covers really, really wide range of scenarios in which we need to cover. Why else do we really need to think about rescue? Well, we spoke about the physical consequences, and I wanted to talk now about probably one of the most confused areas of rescue at height, and that is the issue of being suspended in a harness. Okay, so let's say a fall has occurred and somebody is now suspended in their harness, either in this instance as they're shown here from the front attachment point, or it could be from the rear attachment point. So they're hanging in their harness. There is the potential for what is often referred to as a number of things. Okay, you will sometimes hear this referred to as suspension trauma. You will hear it referred to perhaps sometimes as orthostatic intolerance, suspension intolerance, suspension syncope. Okay, there's lots of different words for it. In the UK, we've moved more towards sort of suspension intolerance or syncope. And what it means is this: if you are head up and motionless and suspended, it can lead to gravity-induced pooling of blood in the lower limbs. Okay, so if you are hanging motionless in a harness, you can end up with gravity-induced pooling of blood in your lower limbs, your legs. This condition can be exacerbated by the lack of movement of the lower limbs. So normally when we move our legs, that helps to force the blood back up towards our heart. If we're hanging motionless and our legs are immobile, lack of muscle pump means that this can be exacerbated, and all this, in what this leads to, is what they call reduced venous return. Okay, the amount of blood which is going back up to the heart to be pumped further around the body again, back through the lungs to be oxygenated, cleaned up the CO2. This can be further aggravated by constriction of the femoral vessels by the harness itself. So not only have you got motionless head-up suspension, gravity-induced pulling in the lower limbs, we've got motionless lower limbs, we've also got potentially compression with these harness straps here of the femoral vessels which run down through your legs, okay, which can increase the risk or increase the lack of blood flow back to the heart. Okay, what this results in is reduced cardiac output. That reduces blood pressure, which can lead to what is often called suspension syncope. Okay, so that is the process by which suspension syncope comes about. This is further exacerbated again by the inability to gain horizontal position. So, I mean, one of the body's natural defense mechanisms to this normally would be to try and get horizontal. Obviously, if you're suspended in a harness, you can't get horizontal because you're restricted from doing so by being hung in that harness. So this can lead to sort of a vicious cycle, which can make the condition worse and worse and worse, and ultimately it has the potential to cause death. Okay, typical symptoms that somebody is going into suspension syncope or intolerance are things like a pallor, a sweating, shortness of vision, shortness of breath, blurred vision, dizziness, nausea, hypertension, and the numbness of the legs. So all of these things, if you have a suspended casualty and they're complaining of these things, those can be examples of the fact that they're symptoms of them going into suspension syncope, intolerance, or trauma. There's lots of different words for it. That's the condition that we are talking about. So it can be a very, very serious condition, and it has the potential to cause serious repercussions and potentially even to cause death. There is a lot of misinformation out there about how long this takes to occur and how long you've got until you die. The honest answer is that I can't tell you how long it will take to occur, because there are many variables which can lead into it. Okay, it can occur within minutes. Most people would likely be showing symptoms after at least 10 minutes. But how long it takes for these symptoms to occur and how long it would then take before it became a serious problem and led to death is almost impossible to put a time limit on. But you do need to be aware that it has the potential to cause very, very serious harm, and it's something that we should take seriously. What are some of the things that can contribute to it? Well, the harness type that you're hanging in or that you're suspended in can have an impact on that. Yeah, here we've got 3 different types of harness. We've got a basic harness, a work positioning type harness, or in fact a suspension harness. So depending on which one you're wearing, depending on how well fitted it is, those kind of things will have an impact on how long you can tolerate being suspended for. Other things that can have an impact: how far you've fallen, how violent the fall was. You know, we know that, for example, when we looked at fall factors, if you have a low fall factor, so you haven't fallen very far, versus a fall factor 2, where you could fall up to twice the length of your lanyard, you're going to see significantly different impact loads between those falls. So those things can have an impact. How hot or how cold it is can have an impact. If you're in direct sunlight, you know that, or if it's very, very hot, or if it's very, very cold, those things can have an impact. How much load there is on you, including all of your tools and equipment, those things can have an impact. And your overall health and general condition can also have an impact on how long you can tolerate being suspended in a harness for. So it's very, very difficult for me to be able to say you've got 5 minutes or 10 minutes or 15 minutes or 20 minutes or any time at all. What's important is that you understand that it has the potential to be quite serious, and it needs to be taken seriously, and you need to be aware of it. What I would say is that post rescue, I'm going to tell you what the guidance is in the UK, and I would encourage you to understand what the guidance is globally. So the HSE did a report, the Health and Safety Executive in the UK did a report, and their recommendations were that if you're recovering somebody post-suspension in a semi-conscious or unconscious condition, that there should be no change to how you recover them. So that is that you would put them in the recovery position, if provided they were breathing. Similarly, there would be the UK says that no change should be made to the standard guidance with regards to management of airways, breathing and circulation. Okay, so that's the UK's position. I would encourage you to understand what the position is globally, because it may differ. But one thing I would say is that if you have had somebody who is in suspension and they are complaining about some of those symptoms, or they have been suspended for a length of time, it would be advisable to have that checked out by medical professionals and advise them that that was the case, so that they can take the appropriate measures, make the appropriate checks. Okay, so that's suspension intolerance, as we've called it for the purposes of this webinar. Important to understand what it is, how it's caused, and what the potential consequences are. So what can we do about suspension intolerance? Well, one of the things that we can do is we can try and take the pressure off the legs. Okay, so we can try and either raise the legs, perhaps by somebody if somebody can get to you and they can raise your legs, maybe at a similar level they can get and raise your legs, or through the use of what we call suspension traps. They're straps. They're sometimes called trauma straps, and they are this device here, which can be either comes as standard on harnesses or can be retrofitted to harnesses, and these can be used to take that pressure off the legs and help the circulation, keep that circulation of the blood moving around your legs. And so we've got a couple of videos that that actually show how that works. I'm just going to play this first video that shows you the principle of the suspension straps and how they work. So you can see that they're stored on the side of the harness, pretty easy to get to, coiled up there, so they can be simply unzipped and unfurled. And then the straps themselves are joined together, and there's various points at which you can join them together depending on how long you want them to be. You can see the options there for connecting the loops. And what you're able to do is actually stand up in these, take the tension off your the straps that are passing between your legs. So you can see here how you can adjust them to be slightly shorter if you need them to be, and then step back into them. You can see when you step into them, what that does is it takes the pressure off the straps that are passing between your legs. That can help to relieve that pressure and keep the blood flowing around your legs, stop that gravity-induced pooling within your legs. And again, once they've been used, they can be rolled back up and stored on the harness itself. So there is something that we can do. There are things that are available out there to try and reduce suspension intolerance in the form of these trauma straps. So what if the harness that we've got doesn't come with them? Well, they can be retro added. So a number of harnesses come with these supplied as standard. Alternatively, they can actually be retrofitted or added to a harness. So if you've got harnesses without these can be retrofitted onto the harness fairly easily, fairly quickly, so that you can convert a harness that doesn't have trauma straps into one that does. It's a fairly straightforward process of simply adding that into the harness. So there we can see we've added those in on either side in terms of adding that capability. Okay. All right, so we've had a look at suspension intolerance. Let's have a look at now who can carry out the rescue. Well, and quite often we'll hear, well, can I rely on the emergency services to carry out my rescue for me? Again, I would encourage you, this is a global webinar, so I'd encourage you to understand what the rules and regulations state in your country or location. But in most cases, it is not acceptable to rely on the emergency services to provide rescue cover. Okay, the reasons for that are mainly you don't always know that they'll be available. They may well be out involved in something else, and their rescue services might not be available. They might not always have the right equipment. Okay, if you just call the ambulance or the medical service, it may well be that they don't have the equipment, or in fact, it's probably likely that they won't have the equipment to carry out a rescue from height. If you call the fire service, of course, they're more likely to have the equipment, but they might not always be available. They might not be able to get to you in a reasonable amount of time. And they might not always have the equipment needed to effect a rescue. Okay, especially if your rescue is being conducted from very high or with particular things that need to be considered that make it quite difficult. Okay, so in most cases, it's not acceptable to rely on the emergency services. There are exceptions. Okay, I am aware of some sites that have got maybe their own emergency services that are available to provide this cover. But as a general assumption, it's best not to rely on the emergency services. It's best to cover the need for rescue with yourself within the plan. Okay, what does rescue not allow us to do? Rescue is not an excuse to be a hero. Okay, rescue does not mean that we can throw all of the other health and safety considerations out of the window. Okay, it is not a chance for you to go putting yourself in danger in order to try and save somebody else's life. That's not what rescue is about. Okay, partly, and the main reason for that is the quick question here: what's worse than one fallen or suspended casualty? The answer to that is 2 fallen or suspended casualties. Okay, so no one's going to thank you for trying to be a hero or trying to put yourself in danger in order to rescue a casualty, because the risk is that you will end up as a casualty yourself as well. Okay, it's important that rescues are planned, they're thought about, they're considered, so that if the need arises, you can put into place the action plan without putting anybody else at risk. The objective of a rescue is that you rescue that person safely, with the emphasis on the word safely. This is not about putting yourself at risk in order to save somebody else. Okay. When it comes to rescue, I always recommend doing one thing, and that is the acronym KISS, which there's numerous different versions of it, but the one we prefer to use is keep it super simple. Okay. A rescue situation is quite often a high pressure scenario. Okay, it's likely that the person will be quite distressed if they have fallen and become suspended in a harness. It's potentially that they may well have injuries associated with that fall, and it can be an incredibly stressful situation. It's also, in the grand scheme of things, incredibly unlikely to happen. Okay, so this means that in reality, you're not going to be doing a rescue every single day. Okay, the likelihood is it will be highly unlikely that you'll have to be involved in a rescue once in all your time working at height. So when you do come to use it, always try and make the rescue that you're going to use as simple as possible, because the likelihood is you probably won't have used it, seen it, or tried it since you last trained on it. So I would always encourage you to keep whatever rescue method you're going to choose super simple. That way, when you need to come and use it, when you take all of that rescue equipment out of the bag, it will be easy to remember how to use it and how to effect that rescue as quickly and as safely as possible. It's also critical that we train and practice, okay? So it's important that we select the right people. You want people that are going to be able to carry out that rescue plan in a calm and effective manner. It's important that we practice in a realistic scenario. So we have some realistic scenarios in which people can practice using that rescue equipment so that when they come to use it in real life, if ever they have to, it becomes an automatic mechanism. The training can kick in and they can recreate what they did in training. So I would encourage you to replicate the pressure of a real life situation and see what happens. See how you react. Put yourself up against the clock in a training scenario. See how long it takes you. See if there are things that you can do to make it smoother or quicker or swifter to effect that training. And as you learn from those trainings and practices, you can modify your plan accordingly and make changes. Okay, so never just get your rescue equipment, purchase it, put it away in the cupboard, and then go, that's for if there's ever an emergency. Because when the emergency comes, someone's got to get that rescue equipment and know how to use it. So it's really, really important that we choose the right people and that we train and practice in a realistic scenario so that if you do ever have to use it, you'll be able to turn to that training and effect a safe, quick rescue. When it comes to rescue, we've often got two choices. We can either try and raise a casualty or we can try and lower a casualty. In nearly every circumstance, if you can, it is always preferable to try and lower a casualty rather than raise a casualty. Why is it always better to lower a casualty? Well, mainly because you've got gravity on your side. It's an awful lot easier to take a casualty and control and lower them to the ground than it is to try and raise them up. If you have to raise a casualty up, you're going to need a mechanical advantage. So you're going to need some kind of piece of equipment that's going to give you a mechanical advantage to lift the casualty and rescue them. So it is always preferable to try and lower them. One thing that you will never be able to do is reach over and lift a casualty on your own. I've in training before, I've heard someone say, well, couldn't they just be pulled up over the edge using one or two people? We've set that up in training and let people have a go at that. It's absolutely impossible. A dead weight of 100+ kilos hanging on the end of a rope over the edge of a building is virtually impossible to lift that person up. Okay, so if you're going to raise a casualty with confined space, it's often the only way that you can do it is to raise them up. But if you're going to raise a casualty, you're going to need a mechanical advantage to do so. So our preference would be always to try and lower the casualty to the ground. It will be a lot easier because you've got gravity on your side. So we've had a look at why we need to do rescue. We've understood the potential problems of being left suspended in a harness. We've had a look at some of the things we should and shouldn't do. How do we put all this together? Well, we need to put together a rescue plan. Okay, so as we mentioned all the way at the beginning, the rescue plan should form part of your work at height plan. So your work at height plan is going to detail how you're going to get there, how you're going to get to height, how you're going to work safely, what measures you're going to use. And if rescue is required, it's also going to detail what those measures are and record them within that work at height plan. So the rescue plan is an important part of work at height planning. Okay, so what are the things that we need to do? Well, the rescue plan should be appropriate to the risks. Okay, a rescue plan does not have to be ridiculously complicated with incredibly complicated rescue equipment with ropes and pulleys and winches, when the rescue plan could simply be that you move in a scaffold tower, or that you use a set of steps, or that you recover the casualty with a platform. Okay, so make the rescue solution appropriate to the risks that there are. Okay, so there's no need to overcomplicate it. You don't have to choose the most complicated rescue solution out there. In fact, as we said with Keep It Simple, keep it super simple, is choose the most appropriate rescue for the risks that are there. Don't overcomplicate it. We need to pay a particular attention to where the work is taking place. A rescue that involves being up a tower or working on steel work is going to be incredibly different to a rescue that involves working in on a scaffold or in a wide open space, or perhaps in a confined space. So we need to understand where that work is taking place, because where the work is taking place is going to dictate what type of rescue we're going to need to effect and what type of equipment we're going to need. We also need to think, how will the rescuer gain access? How are they going to get up there? It may well be that they will need equipment in order to climb the ladder as well. So the rescuer may need to have a shuttle for climbing a fall protection system on a ladder, if that's how they're going to get to height. It may well be that they might need to gain access via free climbing. Okay, so it may well be that they need to structure climb, or they need to climb a scaffold if it's scaffolding rescue. It may well mean that they need to use powered access equipment, so they might need to use cherry pickers or mutes to gain access. Or it may well be that they can simply walk into the rescue scenario via normal means of access. But we need to think about, is there anything special that the rescuer is going to need in order to get to a position where they can effect the rescue? We also need to think about how many people are affected. In an ideal world, we'd only be rescuing one person, if at all. But in certain circumstances, it may well be that we need to have the capability of rescuing more than one person. It's important that we take that into account when we look at our rescue planning. If there's the potential that we need to rescue more than one person, then our rescue plan ought to take into account for that, make sure that we've got the right amount of equipment, that we've got the right amount of people properly trained, and that we are aware of where all of those scenarios are, so that we can manage our rescue planning accordingly. Okay, so important to understand how many people need to be rescued. We need to understand, are there any restrictions that are going to stop us from preventing this rescue? Are we going to have space to operate, to actually carry out the rescue ourselves? Or are we going to need specialist equipment to allow us to effect the rescue? We mentioned about the access, that you might need a shuttle to climb a vertical lifeline system on a ladder. It may well be that you also need work positioning system in order that you can tie yourself off to the structure so that you can work hands-free to effect a rescue. It may be that you're working on a narrow platform or a ledge, in which place you may need additional work at height safety equipment to keep you safe while you're effecting the rescue. We need to understand, are there any weight restrictions to the rescue, particularly with something like the anchor point? Is the anchor point that we're connecting to capable of dealing with the rescue? Is the working platform that we're going from, does that have weight restrictions? Is there anything obstructing us? Is there something in the way that's going to stop us from being able to successfully effect this rescue? And also, is there anything like moving equipment? If we're rescuing near a crane or perhaps some moving machinery, do we need to be aware of that moving machinery and perhaps lock out and tag out before we start to effect a rescue? So we need to think about, are there any restrictions, or is there anything that's going to actually prevent us from carrying out this rescue effectively? And then we also need to think about hazards that could affect us during the rescue. What are the weather conditions like? Is it particularly hot, cold, wet, icy, slippery? Are we going to have to deal with any fragile surfaces? If you're rescuing somebody from roofs, then it may well be that you're having to deal with a fragile surface. One of the things that we need to consider if we're going to lower the casualty is, have we got any obstructions below us? Is there something that's going to stop us being able to safely lower that casualty down? That obstruction could be in the form of a production line. It could be a tank or a pit with chemicals in it that we need to consider before we lower the casualty to rescue. Is it actually safe for us to do that? Is there an obstruction below them that's going to stop that from happening? It may well be that we have to lower them to another platform that is at height and then effect a second rescue from that platform. We need to think about electrocution, particularly one of the common areas there would be something like cranes. You know, if there's the buzz bars or the electrical conduit that runs below cranes, we need to be aware of any risk of electrocution. Are we going to put ourselves at risk as the rescuer, or are we going to risk lowering that casualty into a scenario where they may come into contact with electrical equipment? And hot works, you know, again, is there potential that either you as the rescuer or the casualty that you're rescuing is potentially going to be exposed to heat, particularly relevant within the steel industry? You know, you don't want to be lowering them down into somewhere where there's hot works below. So it may well be that in that scenario, you have to consider raising the casualty because lowering them isn't an option. One of the other things that we must consider with rescue is sharp edges. We've spoken before about selecting the right PPE if there's a risk that you can fall over a sharp edge. So particularly if a casualty has fallen over what we would consider a sharp edge, and their PPE is stretched over that sharp edge, then if we're going to rescue them and lower them, then it's likely that our rescue rope is going to be abrading over that sharp edge. So we need to think about putting in place some kind of edge protection for that rope so that we don't cut that whilst we're effecting the rescue. So we need to think about, are there anything that we need to be taking into consideration in terms of protecting the PPE and the rescue equipment whilst we're lowering that casualty? Because if we're lowering a casualty over quite a long distance and the rope has to deviate over an edge, we're going to need to protect that rope so that it doesn't get abraded or cut during the rescue. We've spoken about the need to effect a quick rescue, so we need to think about how quickly it can be completed. As soon as somebody falls and they're in suspended access, then effectively the clock is ticking, and we know what the potential consequences are. So we need to rescue them as quickly and as safely as possible. So think about if you've got a centralized rescue team, maybe you have one rescue team for an entire site. How long is it going to take them to get there? Okay, maybe you need to have rescue equipment on site with the work that you're doing, or maybe you have a centralized rescue team who can come to an emergency situation and effect a rescue quickly. Whatever your plan is, you need to think about how long it's going to take and how quickly that rescue can be completed. Remember, our goal is to complete this as quickly as is safely possible. Okay. And we also need to think about communication. You know, we spoke about, I spoke about keeping it simple and the need to practice. A rescue is quite often a high pressure situation. If you're going to be lowering somebody or dropping somebody, you most likely want to have somebody on the ground to receive them. So therefore, it's likely that you're going to need to communicate with them. If you're working in a very noisy environment, or perhaps the distance that you're lowering somebody is significant, you're going to want to make sure that you have a way of communicating with the team that you're working with. So that may well be in the form of, could be mobile phones, it could be radios, or it could be comms equipment, such as shown on the screen here. But you want to make sure that you've thought about communicating, particularly if you need to coordinate a rescue with somebody above and somebody at ground level. In an ideal world as well, it would be good potentially if you've got some way of communicating with the casualty if they're conscious, so that you can reassure them of what's going on and what the next steps are and what measures you're taking to rescue them. So that form of reassurance. So I'd always also say, think about how you're going to communicate so that you can effect that rescue safely and quickly. Okay, so we've had a look at why we need to do rescue. We've had a look at the issues around being suspended in a harness. We've had a look at the types of rescue that we might need to effect, and we've had a look at what we need to do in terms of building out a rescue plan. What we're going to have a look at now is a number of the different solutions that are available that you can consider when it comes to building in your rescue plan. Okay, so the first of those is what we call self-rescue. Okay, so that's the ability to rescue yourself. So if you are working in a situation where you think, I may be in a situation, or so you've done your risk assessment, you've done your method statement, and there is a possibility that you are going to be in a position where you need to rescue yourself. It may well be that you want to have the rescue equipment with you so that you can effect a self-rescue. That way, the obvious advantages of that are you're not going to be waiting on a rescue team. You're not going to be waiting for somebody to come and get you. Okay, so if you can build it in and you can factor in self-rescue, and that's an option, then that removes the need for a dedicated rescue team. That could be in the form of a piece of rescue kit, or it could be in the form of using PPE that's designed to be able to allow self-rescue. We could look to an automatic rescue. So we looked at these types of equipment earlier on when we looked. This is a type of connector, a self-retracting lifeline, or a fall arrest block, or a retractable type fall arrestor, numerous names. This one has a built-in mechanism within it. And I'll just get the pointer here. This has a built-in mechanism in it, which can be set to automatically descend after a fall. So if it detects a fall, it will lock and arrest that fall as usual, as a typical fall arrest block would. And then what happens is, after a period of time, a small period of time, it will automatically go into descent mode. So it can be set to automatic. So if you fall, it arrests the fall, and then it will automatically lower you to the ground. Okay, so the fall occurs, and then the rescue occurs straight after it. So this can be really, really handy if you're working in a fall arrest scenario, particularly if you can get an anchor above your head. If you're in a fall arrest scenario, you immediately know that as soon as the fall has occurred, you will just be lowered at a controlled rate down to the ground. Important thing to consider there is that if you're going to rely on this to lower you down, you want to make sure that there is enough length in there to lower you all the way down to a point at which you can be recovered from. So you don't want to be using a fall arrest block and relying on the rescue function, the RSQ function, if there isn't then enough length in the cable to be able to lower you down to the rescue point. Equally, you want to make sure that if you are in this scenario, that it isn't deviating over a sharp edge, okay? Because you don't want that to be paying out over a sharp edge. It could be very similar function. It could be that you work with what's called remote operation of a rescue. So in this scenario, very similar block, or in fact, exactly the same block, that function can be set to remote operation. So in this scenario, if you fall, the block will lock and it will hold you in that locked position. What can then happen is, either by remote activation from ground level using this rescue pole, or if the person can get to the block itself, then they can activate the function, which will then in turn lower you to the ground. We've actually got a video of this one on the next one. One of the things we're working on is putting together videos of these functions. So this is one that we actually have. So let me show you this one and you'll be able to see how this works in reality. So in this scenario here, we've actually got somebody using the M100, M200 that we previously showcased as the anchor point. This is the block with the rescue function. And in this instance, they're operating on top of a vehicle. It could equally be a piece of plant or equipment. Okay, so in the event of a fall, in this instance, the fall arrest block has locked and has arrested the casualty. So we now have a situation where we have a suspended casualty and we need to get that person down. So we could have had it set to automatic, at which point they would automatically be lowered. In this case, the function is set to manual. And so here we can see the rescuer comes in and they have this, the tool, the rescue fork, which is on an extendable pole. That rescue fork can be used, as you'll see here. We'll zoom in on this shot. The rescue fork can be used to activate the RSQ function by pulling it out. And as they pull it out, you'll see what happens to the casualty. They're lowered to the ground at a controlled descent. Okay, so that is either a remotely operated access rescue, okay, or if you'd had it set to automatic, it could have also been an automatic rescue as well. We can also have assisted rescue. So this is whereby we've got a fallen casualty and we're then going to use, working from above, we're then going to use rescue equipment to lift that casualty slightly to release the tension of the equipment they've fallen on. And then we're going to use this equipment, this controlled descent device, to lower them to the ground. There's numerous different ways that you can do this. By far the easiest is this controlled descent device. What this does is that allows you to, the wheel on here allows you to connect this end to the casualty, which can be done with a rescue pole, or it could be done with a rope and grab onto their lanyard. We then raise the casualty up slightly to release the tension on their connecting device. We then release the connecting device, and then we can use this rescue equipment to lower them in a controlled manner down to the ground. Okay, so this would be a third party or an assisted rescue, generally conducted from above, so it does require you to be able to get above the casualty. Okay. We could use access equipment. Okay, there's nothing wrong with a rescue plan stating that you could use a ladder, you know, the portable ladders that we've shown in some of the other webinars, or you could use steps or a portable platform to bring it under the casualty. If the casualty has not isn't too far off the ground, it'd be perfectly reasonable to use those function, and they're conscious, it would be perfectly reasonable to use those to allow them to climb onto and come down. We could use a MEWP or a cherry picker, so we could come up under the casualty and rescue them, or we could use a scaffold tower if that's appropriate. So we don't always necessarily have to have specialist bespoke rescue equipment. We could use access equipment that's already readily available to us. We could use an accompanied rescue. This is getting more into the specialist type of rescue now. And this is where where the rescuer is not operating remotely, it's where they're coming down to the casualty. And they are then either connecting themselves to the casualty and lowering them down and coming down with them, or they're affecting the rescue in the position where the casualty has fallen. More likely, you're going to see this on things like structure or perhaps from ladders, where you've got to get up to the casualty before you can effect a rescue. If it's a rescue from sort of rooftops, it's more likely to be the assisted rescue, where you're working above the casualty. But it may well be that you, the rescuer, needs to come down to the casualty to effect the rescue. Obviously, far greater risk involved in this. You're going to need quite a lot of specialist equipment to allow you to safely operate in that environment. So it's going to need more equipment and it's going to need a higher level of training. But it can be a way of rescuing, particularly if you've got difficult access. If you're working in very restricted access, like up a tower or a ladder or structure, for example. We may need to look at using equipment to rescue somebody on the same level. So we've spoken about lowering somebody to the ground. It may well be that we need to use mechanical advantage equipment to actually rescue somebody on the same level. Okay, so this is where we're using equipment. Again, we may be using a a pole to reach in there and connect the rescue equipment to them, or it may be that they've gone in with rescue equipment already attached, so that if there's a problem and they need to be evacuated, you can then use that rescue equipment to pull them out of that scenario. So it's not just lowering a casualty with regard to rescue. It can also be evacuating a casualty sideways or at the same level. I'm not going to go hugely into depth on these and the equipment, because we do have a webinar coming up on confined space which will look at this in greater depth. And we have the below ground rescue as well. Now, in this scenario, you're almost certainly going to have to raise somebody up, because if they're below ground, it's unlikely that you're going to be able to lower them down and then evacuate them. Maybe you can. There may be an exit at the bottom of a tank, for example. There may be an access hatch. So if somebody becomes falls inside a tank or a pit, for example, it may be possible to lower them to the bottom of that tank or pit and then rescue them at the bottom via an evacuation hatch or an access hatch. But likely it's possible. If they're below ground, that you're going to have to raise them up. Okay, so you're going to need a lot more equipment in the form of perhaps a tripod or a davit system in order to raise that casualty up. And you're going to need something that creates a much greater mechanical advantage to give you the possibility of lifting that person up. We also then have evacuation. Okay, evacuation is not where you're in a fallen scenario. This is where you need to get out of a scenario of being at height quickly. So, for example, working in the cab of a crane. In this instance, you're going to want to have the evacuation equipment with you. It's not a case of somebody coming to rescue you. This is a case of you rescuing yourself quickly and efficiently, evacuating yourself, quickly and efficiently from a scenario by which you can't use your normal means of access and egress. So perhaps the ladder is incapacitated due to damage or due to fire, or perhaps the stairs are incapacitated for various reasons. You need to be able to evacuate. You're going to want to have that kit with you. And again, this is the controlled descent device. You're going to want to be able to get that harness on, connect yourself up using the controlled descent device, and then lower yourself down to safety. Okay, so those that came to the safety day will have seen this in demonstration from the wind turbine setup. Equally, exactly the same from cranes, gantry cranes, tower cranes. The rescue scenario will be exactly the same, except you're going to want to have that rescue equipment with you to effect that rescue. And then the final one that I just want to touch on is what I would call complex rescue. It may well be that within your rescue plan, you've looked at it and you actually end up needing a complex rescue. It might need rope access. It might need abseil. You might need to deviate the casualty. You can't drop them straight down. You've got to bring them out at an angle. It may need stretcher recovery. If you are into this kind of rescue and recovery, you're going to need very specialist training, and it may well be that you need to bring in specialist rescue cover in order to cover the work that you're doing. It may well be that the training you require means that you actually need to bring in maybe third-party cover to help you in this scenario. So if you can't solve it using one of the sort of methods that I've described above, and you think it's going to go into complex rescue, it would be advisable to reach out and seek the advice of a specialist rescue company who can advise you on that. Because once you start getting into stretcher recovery, moving the casualty on an angle, that becomes quite specialist rescue. So you're going to need specialist equipment and you're going to need specialist training in order to be able to do that. Okay, so as a recap then, we're coming up to time. We've had a look at what rescue is, why we need to do it, the types of rescue that there are. We've had a look at the issues around suspended casualties, and particularly what's often called suspension trauma or suspension syncope. We've had a look at the considerations, things we need to take into account when effecting a rescue, what we need to do to build a rescue plan, and the various different types of rescue scenarios that there are that we can use to solve, the equipment that we can use to solve our rescue problems. So hopefully you found this an informative webinar. I'll take this opportunity to say thank you very much for your time. It's been an absolute pleasure to talk to you. And I guess, Andy, if we've got some time, perhaps we can maybe just grab a couple of questions.
Thanks, David. That was an excellent presentation. I learned an awful lot from it, and we do have some questions, which probably isn't a surprise. It's a very, as you said at the start, a very popular topic.
Yes.
So maybe I'll just dip into those.
Yeah, fire away. Absolutely.
First one. I mean, I'll say a word, then pass to you. Ernestas is just asking whether we have any statistics how often falls happen. I did say before I do want to say before I give David the mic, Ernestas, from a steel industry perspective, I don't have frequency rates for falls with me. If you're a World Steel member, you can look at our metrics survey and see that. But I would say last year we had 99 fatalities reported to World Steel, and of those, 17 were a result of falling from height. So this has been consistently top 5 last year, the top cause of fatalities within our industry, which is the main reason that we've chosen this topic and given it quite so much focus this year. But David, I don't know if you have any thoughts on how falls happen.
I'd echo exactly what you said, Andy. I mean, we know if we look around the globe, we know that work at height, and particularly falls from height, is always either at the top or near the top of the statistics. I mean, I guess perhaps one maybe the question you might condense it down a bit and say how many rescues are there. That's unfortunately the sort of granular data which is very hard to collect. But I guess if you thought about it and said, if you had 17 deaths from falls from height, if those had been wearing fall protection equipment, then it may well have been 17 rescue scenarios that we might have been affecting rather than having 17 casualties from falls from height. We don't have statistics on how many rescues there are. I mean, honestly, good rescue planning starts with right at the beginning and trying to stop the fall in the first place. But I don't have statistics on how many rescues there are. Yeah. In all honesty, it's highly unlikely. Because once you start planning for work at height and taking the appropriate measures, hopefully you shouldn't get to the point where you need a rescue. But it's important that we have those plans in place. So I don't have statistics on how many rescues, unfortunately, but in terms of work at height and accidents, and it's always near the top of the tree in terms of fatalities.
Well, I can say last year we had 150 lost time injuries reported to us. As a result of falls from height, and to be honest, 150 versus 17 fatalities is a rather frightening ratio, and one of the ones that would cause us a lot of concern. So that's not a lot of lost time injuries to have that many fatalities.
No, it's not. No,
critical issue, which is why we're doing all of this. So I'll move on to another couple of questions and points we've had in.
Yeah, sure, no problem.
But for crane operators specifically, is self-rescue an appropriate tool, and does it require very complex training if you're going to use that?
Yeah, sure. Again, it would all come down to risk assessment. So, I mean, is it appropriate? Yeah, absolutely. If you've conducted a risk assessment and says, we've only got one way of access and egress to this crane, if that access and egress is compromised, and there's a likelihood that it could be compromised, and we need to we would end up in a situation where we would have potentially somebody stranded in a very dangerous situation in a crane cab. So absolutely rescue or evacuation from that is a viable option. In that scenario, is it difficult? Is it complicated? No, it's actually a very straightforward procedure. The controlled descent device is designed to be quite intuitive. So literally you need an anchor point, you have the device, and you have a harness. The user puts the harness on, they connect the controlled descent device to the anchor point, themselves to the end of the rope, and then you can simply step out of the cab, and the controlled descent device does the rest. It will lower you to the ground, as the name suggests, at a controlled speed in a controlled manner, such that you can evacuate down to a safe space. Obviously, you want to make sure that below you is safe to evacuate into and that you've been appropriately trained, but it is not difficult and complex. So it's an entirely appropriate measure that you can take as a way of providing safe evacuation for those who are operating at height.
Great, thank you. Here's another question from Alan in Corby. They've done some training up there, and the advice they had after rescue is not to lay a casualty down, said Alan, but to sit them against a wall with their knees up. Do you have any perspectives on
where
to do that?
It's really interesting. So, and this is where there is contradiction within the industry. So the advice I read out today comes, if you go onto the HSE, which is the Health and Safety Executive in the UK, and they have a report around post suspension recovery of a casualty, and within that, their advice is that you recover somebody to the recovery position, because it's not, the likelihood is that you as the rescuer are not medically trained to be able to make an assessment as to what the right thing to do is. So what I would encourage you to do is, if you have if you have a casualty who's suspended, is you would want to make sure that, and they are going into suspension syncope, and you think that, that they are showing the symptoms of this, you would want to get the emergency services en route to you so that they can treat that casualty when you've rescued them down to ground level. But I would strongly encourage everybody to read and understand the literature that is available in their country. And if you go on the HSE, which is the UK's website at the moment, their guidance is clear on the post recovery of somebody who has suffered suspension.
But would you always seek medical guidance after the fall, David, even if someone appears to be okay and is walking around?
Honestly, I would, as a precaution method. If somebody's been suspended in a harness, I would advise them to get checked out by a medical person, and advise that medical person that they have been suspended in a harness, because you don't know what the potential consequences might be. So even though they're completely okay, if they've been there for a very, very short period of time, you lower them down, they effect a rescue, then they're fine. But if they've been suspended for a period of time and they're complaining about any of the symptoms, or they're feeling unwell, then it would always be advisable just to have that checked out and make sure that there is no consequences.
Yeah, that's sound advice, I think. One of the things you talked about towards the beginning of the presentation was how long it takes for someone to start suffering from a medical condition. It varies. Is there kind of a target for how long we should be aiming to rescue somebody, to try and stay,
Yeah, sure. That's a very good question. So my personal preference is, and I don't like putting a time limit on it, because the danger of putting a numerical time is, if you go over that, then you start to say, well, okay, I've gone over that, should I rescue them? The answer is, you should have a plan that allows you to rescue them safely and as quickly as is reasonably possible.
Sure.
So if somebody falls and becomes suspended in a harness, you would want to have a plan in place that allows you to effect that rescue within a reasonable length of time. So within 5 to 10 minutes, you would want to have somebody rescued. Okay, so that's a reasonable guide. You'd want to have a rescue effected within a period of around 5 to 10 minutes. But I wouldn't want to I don't like putting time limits on things, or I don't advise putting time limits on things, because the danger is that people get close to that and go, oh, well, it's too late. Okay, if somebody's suspended, they need rescuing. And it's imperative that we have a plan in place that allows it to be rescued quickly and safely, as quickly as possible, safely.
That makes sense. If it's me, I'd like you not to give up, because it's
yeah, exactly.
That's right. And on that note, perhaps that's a good time to wind things up. We've gone on a little bit, but I think given the presentation and the great questions engagement you had, that was worth doing. I think, David, we're going to share your contact details on the screen. I think we have a couple of folks. Do we have a slide with Dave's details?
I don't have mine, but what I do have is all of the World Steel contact details, and any questions that you may have. If you forward them on to yourselves at the any of these contact details here, I know you forward them on to us, and we will always move on and answer.
So I'll address Gary directly, who asked for your contact details. Gary, if you could email perhaps us at safety@worldsteel.org, we will absolutely pass your details on to Dave, and then you can talk to each other about, because there's a gentleman who's looking for some more details.
Yeah, no worries. I've just popped up the question there. Always, yeah, absolutely happy. Please pass on my details and.
Or after the session, maybe you just type your answer in there, David, and then you can.
Yeah, no worries. Yeah, I will do. Yeah, absolutely.
That's great. Look, this was a great session. As always, we have made a recording of the presentation. A few folks were asking about that as well. My colleagues at Steel University will do some work to top and tail and edit and really make this into a bit of a course. So there's full access to the presentation, full access to the slides. Generally, that takes a few days. So I would keep your eye on the Steel University website. There's a whole section where you will find not only this webinar in a few days, but you will find a whole library of previous webinars that we've been working with 3M. There should be another 7 or 8 there, covering different aspects of working at height. This is not our last webinar. We will be running another few as we go through the year. David, I don't remember the next one. It may be.
I need to check. You've got me on the spot there. I think it might be. It may well be confined space, but I'll have to have a quick check. But I know that we go out via all the usual channels to advise everybody beforehand.
Please keep an eye on our socials at World Steel and Steel University, LinkedIn, Twitter, etc. And if you're part of this webinar, you'll be almost certainly on our mailing list, or will be soon. So you'll get to hear about it. I'm looking forward to that one too. So I think I will close at that point and thank everybody who's given us their time to be part of this. Thank you, Dave, as always.
Always a pleasure.
For your inputs and your expertise. We'll close the webinar now. So thank you all and good day to you.